Okay, I've already said, put a pretty wide curve on these tests. But given how well you're doing, homework and preparation, you want to get a little better at preparation for the exams. But there was definitely improvement in overall preparation when you look at the class as a whole. This is a harder test. Some people scored lower than they did on the major quiz, but a lot of people scored higher. Okay. I think that the higher is kind of beat out the lower. And the ones that went lower didn't go that low because everybody used to see. Now, this is a wide curve. I'm talking about 50%. It's 50% of a fairly challenging test. And even people that made grades in the 50% range did some things that were really good. Okay. So I'm real well convinced that I'm not dealing with any people that don't have good ability. Okay. Maybe a little more preparation. And what I'm thinking about is a little more drill and practice. So I've already made up a wonderful set of 72 randomly generated problems and exponential functions. You're going to love them. Actually, no. You're going to love some of them. Because I put everything that I think a pre-calculus student reasonably ought to know. It really isn't so. Okay. Because of all kinds of reasons, because I think the problems, the way things are taught in the first place up to this point. Just general national, I'm not talking about local. We have wonderful teachers. Every teacher I know it's wonderful. Okay. I'm sure there are some that aren't. They just try to avoid me. They don't want to disillusion me. No, I'm sure there are, because every profession's not even. I mean, look, I'm teaching college. How could that be? Okay. You can be totally incompetent to teach this stuff. Okay. Now, seriously, I think I'm at least semi-competent. Okay, again, there's a wide range here. I don't see any reason people who are in the lower realms of the C's, anybody in the C range can't get themselves into the B range. Okay. I think everybody's smart enough. So I am going to be giving you some drill and practice problems, probably starting next week. The ones I did on exponential functions get into some, half of them are pretty tricky. Take some real depth of knowledge. So if you want to challenge yourself, okay. But I'll kind of separate those out. I'll give you the standard problems and the challenge problems. Okay. I'm also going to do kind of a set of minimal problems. I kind of sketched that out this time. Just the really foundational stuff. If you really know, you shouldn't be in any danger of dropping below a C on the exam, on the final exam. Okay, just something for you to focus on. And you know, I had a guy back 15 years ago. He was in my governor's school, came here as a high school junior, took our most advanced courses along with a couple of his buddies, and they knocked the top off of things. And you know what, I ended up with a PhD from University of North Carolina, was for a while over Duke's liberal arts math class. Okay, as a postdoc. He had they gave him an extra year of postdoc. He had 3 years as a postdoc. He's now a trainer for Google. Okay, really smart guy. Another one went to Harvard and nailed their freshman math course, which has twice as much math in it as the average high school teacher ever knows. Okay, really smart and totally off the wall in the way he'd solve things. You look at his solutions, you think, how did anybody think of that? That's weirder than what I would do. And it works. And he's really good enough. Okay. Making a lot of money doing some really interesting stuff. The other one, the third one that I kind of lost contact with, graduated from Cornell with a degree in economics. Pretty mathematical. So I think he's doing just fine. That's related to this somehow. Description, but anyhow, yeah. There's lots of this. The guy with the PhD, and I can't tell you which of the three was the smartest. They were all just top notch. But the guy with the PhD went on to University of Virginia for his undergraduate and wanted to graduate early, but he couldn't work a course in complex variables, senior level course in complex variables. Okay. He was working for me in the summers as a work study. Because it's kind of a summer job for the summer. So he asked if it was possible for me to do that. And he said, yeah, well, that was my specialty. I could easily do that. If UVL allowed. Well, I sent my credentials off and said, yeah, you can do it. By the time we got all that approved, we had 2 weeks left to do it. This is a pretty advanced course in complex variables, which I hadn't looked at for 3 years. But I knew it. So, we worked through it. He worked all the hard problems in the text, answered questions. I gave really good hints. And he said afterwards, well, that course was really good. It really prepared me for my PhD qualifying exams, which requires a graduate level course. And he's trying to give me credit for that. And I said, wait a minute. I showed you the fundamentals. Okay. And we did a good job of that. I've got some real insights. I spent a lot of years studying this stuff. And a lot of it came back to me. Everything's fell into place very nicely. So I gave you some good stuff, but you're giving me too much credit because I don't know that I could have taught you a good graduate level course in this stuff. Okay. At one point, I probably could have just 3 years later. I said that, the credit is with your aptitude. You were able to take this core that I gave you and expand it into this. Okay. Well, that gets back to what I was saying about an hour ago. If you get this core that I'm talking about, then it's your aptitude and your interest and your curiosity. It depends on how big you can expand that core. Okay. Now, with all the other stuff we have, I don't see anybody in this range that can't get into this range. Okay. Just from that core and putting it together with all the stuff that we have. Okay. I'm going to give you a little more than that. So that'll start coming out next week. Look forward to it. Because another thing is we're getting to the end of the hard part of this course. Just about there. Next week, we're going to get into the easy part. And you have time to bring the hard stuff together. Okay. And the easy part is solving simultaneous equations. And then even easier setting up this matrix equations. Okay. So you want to focus on that. But you want to really focus on the essence of this course. And we're going to try to pull that together in such a way that you all can do what you're capable of doing, if you have time to do it. And I'm going to be one limitation because you got other things to do. And how much can you take that core and expand it? Some people expand it, you're not, you know that. Okay. But everybody can go from, everybody in this range can go to this range. And other people in this range can go to this range. Okay, some people aren't that far from this range, and a couple of people are well within this range already. Okay, so that's what I'd like to see, and I think that's what I'm going to see, given how you all are working. Okay, well, with that, never mind what was going on. And we want to talk about more about applications and interpretation of your results for exponential functions. We've done most of this already. So let's say the mass of a plant. Incidentally, I have recent experience, mass of a plant. My wife decided she wanted to get some microgreens, couldn't find them at Kroger's, went to the farmer's market, spent $25 on little trays of microgreens, not many microgreens, but well grown. Okay. Brought them home, sat around for 3 days. They kept growing. It's okay. She finally started eating them and realized the stems were hard for her to swallow. Wrong with her. I mean, this physics. Yeah, she's great. And nothing wrong with her swallowing ability. Okay. You know, the problem is I can't hear what she says. You know, I don't have a way to turn my hearing aids off. I can turn them down, but I can't turn them off. Okay. Anyhow, she finally said, "You gotta have to eat those things. You know, you have to find out if you like them. You know, you want me to throw them. Yeah, I can throw them for you." Turns out she comfortably swallowed. So she cut them off and put them in bags. So I better eat those things. I paid $25 for them. It's about 2 mouthfuls. It's more than that. I was going to eat them this morning, but she put them in the bags yesterday and left them sitting out. They didn't smell too much. So I decided maybe I didn't want to eat them. So it cost worth $25 to find out if I don't have to go buy them. Okay, not that I want to mind it. If she's going to eat them, I'd enjoy growing. Okay. With that background, the mass of one of those plants, if it has room to grow, tends to grow exponentially. Reason is, the more plant you've got, and the more roots it's got to absorb nutrients, and the more sunlight it absorbs to make use of those nutrients and grow more. The bigger it is, the more it grows. Now that when it starts to reach maturity and starts to produce seeds and all that stuff, you know, everything goes to heck. Okay. And the exponential growth no longer applies. But if you give a plant enough room, it'll grow exponentially for, you know, several weeks. And some plants, well, yeah, that's okay. Anyhow. So your first model is a massive plant grows exponentially. So I'm going to say massive plant increases at a rate proportional to its mass. Now let's do an analogy. You've had examples of compound interest, okay, of investments growing with interest. The more money you have, the more interest you get. So the rate at which your money changes, the value of your investment changes is proportional to your investment. Okay. If you got twice as much money, you get twice as much interest. So the rate of change is proportional to how much you've got. Okay. So let's call the mass M. Rate of change of M is proportional to M. Now, one question you could see in your final is, what's the condition for exponential growth? This is it. The rate of change is proportional to how much you have. If you got a herd of animals, the more animals you have, the more babies you get. Assuming you let them freely intermingle, sometimes you control, reproduction rate. But in a natural setting where there's enough food and enough space, that's how populations go, because the rate of change of the population is proportional to the population. You got twice as many animals, you get twice as many babies. Okay. You got twice as much money, you get twice as much interest. Okay. So we talk about the rate of change is proportional to how much you've got. Now we have to distinguish rate of change from growth rate. So it's an important thing. Rate of change is delta M over delta T. Change in M divided by change in time. It's the slope of your graph. Okay. If you have a constant growth rate, you get an exponential graph. If your money is growing at 5%, then the more money you have, the more you get, and your graph has an exponential shape, familiar exponential shape. Obviously, the rate of change keeps increasing because the slope keeps increasing. The growth rate doesn't change. Okay. ROC much standard abbreviation for rate of change. Rate of change keeps changing. Growth rate, which we use standard notation as R, stays constant. So that's important. That's kind of a side note to the problem I'm going to pose. If this is the frame of any problem where the rate of change is proportional to how much you got. So the mass is an exponential function of time. Okay, well, if the mass is 2 grams, it's equals 5 days. It's 7 grams, it equals 14 days. Can you find the exponential function? Okay, now the first response I got was, well, find the rate of change, because when you have this information, it's totally natural to find the rate of change. Change in the mass is 2 grams to 7 grams is 5 grams. Time is 5 days to 14 days, that's 9 days. So it's 5 grams over 9 days, 0.55 grams per day. Actually runs up to 0.56. Okay. So that's an important quantity, but it doesn't help us find the function. Okay. But that's certainly something we can find from this information. And as long as it doesn't distract you from finding the function, when you see that information, if you've got unlimited time, which you do, okay, it's fine to calculate it, and then you can kind of see how that fits into the function once you get the function. Okay. Okay, so that's a good thing, because again, when you see a problem, a good way to start a problem, if you're not sure how to start it, is do something that makes sense. And finding the rate of change makes sense, but don't confuse that with the growth rate. Okay, what I wrote in red here, because it can distract you. Okay, so we want to find the function. So any other suggestions about the first thing we want to do in order to find the function? We want to find the exponential function m of t from this information. What's a form of an exponential function? There's 3 possible forms. The simplest is ab to the t, but we eventually want to be sure that we understand how to relate this to the other 2 forms. Okay. So the correct form, somebody said it, is m of t equals h to the t. That's the easiest form to use. Okay. Okay, well, how do you use this? Well, the next thing you want to do is you want to sketch a graph with your information. I eventually want to do a better sketch, but for right now, I'm just going to say, here's your value m, and ground, and here's your value t in days. Now you probably can't write 3. That just says t days m grams. Okay, probably readable on the screen. Write that out, and then we can put 2 points on the graph. At t equals 5 days, m is 2 grams. At t equals 14 days, m is 7 grams. Maybe 7 is up here. So I've got the points 14.7. And 5.2. Okay. Now, how do I find the model? Well, time isn't really pressing that hard, but we want to say several things. But we've done this. I've given you problems where I gave you 2 points and said the form is A, B to the T. And to plug the points in and get 2 simultaneous equations, solve for A, plug it into the second equation, and so forth. So that's a process that I have to assume that I'm just going to write it down quickly. You get make sure I've got the right numbers here. 2 equals A, B to the 5th. And 14. No, 7. Equals A, B to the 14th. Okay. Now, these aren't linear equations, are they? Neither of these equations can be put in the form y equals mx plus b. Okay. Neither of these function. Well, this function isn't linear. It's exponential. It's like this. It's not like a straight line. Okay. Well, we solve the system. And we get the first equation tells us that A equals 2 over B to the 5th. And then we plug that into the second. That means that 7 equals 2 over B to the 5th times B to the 14th. So we get B to the 9th. 2 B to the 9th equals 7. B to the 9th equals 7/5. B equals 7/5 to the 1/9 power. Now, we did that slowly in class. We told it. But that's what we have. And then you get me to make a bad approximation. Okay. So let's see. 1.1 squared is about 7/5. 1.1 to the 4th is about 7/5. So 1.1 7/5 to the 1/8 be about 1.05. So I'm going to say B is about 1.04. Okay. Now you can use your calculator. Use 1/9. That's easy. And that's legitimate. You don't have to approximate in your head. You see me approximate things in my head. Usually I'm not too far off. Sometimes I'm totally out the ozone. Okay. But yeah, I actually think it's fairly close. I just checked it another way. Using Dudley twice and stuff. Okay, so at this point, we make a little note. The growth factor is 1.04. Growth rate is 0.4% because that's what B tells us. B is the growth rate. So now, M of T equals A, whatever A happens to be. Times 1.04 to the T. A equals 2 over B to the 5th. Okay, and B to the 5th is about 1.2. So I'm just gonna make not a totally wild approximation. It's 2 over 1.6, over 1.6, it's about 1.6. And my function is approximately 1.6 times 1.04 to the t. Now, all these steps are easy. Use your calculator. And again, we've been over it, so you might want to review it. And you can open math is asking to do some of those, okay? So make sure you get from here to here. And now let's see what we can answer about this function. What could we do with this function? Well, we want to harvest this. What the mass is 1,200 grams. Now remember, this is just a baby, right? At 14 days. But it grows. Okay. And let's say it continues to grow exponentially. It'll grow up to 100 pounds. It's too tough to eat. Okay. So I'm not sure what place that would be, but so mass is 100 grams, assuming not the best statement, but the idea is you want the domain to be long enough that it continues to grow exponentially up to 1,200 grams. Okay. That's what we mean by that. Well, what is this? It's when M of t equals 1,200, right? Well, how are you going to find out when M of t equals 1,200? So the answer I got essentially told me, well, use the equation. Okay, use the formula. Okay, gives you an equation. We can solve this equation for t. M of t is 1.6. But there's our equation. No, we're going to solve it. But you solved a bunch of equations just like this for homework and did a good job of. So, and you did a good job of this back when we did it. I saw you do it. I swear I wasn't imagining it. Okay. So you might have to review what you did and lock it in. That's not hard. Nothing hard about this except the interpretation, which is a little bit challenging. You gotta get used to it. Okay. So we have the equation. So go ahead and solve it. Well, as expected, everybody do this quite well. You divide both sides by 7.6. You get 1.04 to the t equals 1200 over 1.6. And I said about 730 because I was thinking a little less than 5/3 and stuff like that. The obvious thing is 12 over 16 is 3/4. 0.75, and then you adjust. You get 1.04 to the t. Then you got to get up to 750. Okay. So then t log to the base 1.04 of 750 equals log of 750 over log of 1.04. Somebody, the one number I've seen is around 170, 168 point something. I know that this is going to double in about 18 days. Okay. So in 18 days, we'd be up to 4 grams, 36 days, 8 grams. Okay, how many doublings to get up to 1,000 grams? It's going to take about 9 doublings. 9 times 18 is about 162. So I really believe that 168.7. Okay. Okay. And I'll note that that's 163 days after the 2 gram stage. But you start the calendar, let's say when first seedling first emerges. Now, when it first emerges, it doesn't grow exponentially, it grows faster than that. So I'm kind of assuming after 5 days, it slows down. For the first 5 days, it's just eating seed. Okay, seeds transforming into plant mass. And that kind of depends on how big the seed is, whether that's a reasonable model or not. But right there is just a very typical exponential model. The steps are always the same. And in most of the problems you're going to see in the homework, you don't have to do this. But in some of the problems, you might have to do this. And believe me, on the final exam, you're going to have to do this. Okay? Just make up the whole thing. Now, other questions they ask you that are really easy. Here's the function. What is it after when t equals 14? Okay. You just plug it in. And you know that. I don't think anybody would fail to do that, judging from the fact that everybody very quickly solved this equation. You're well prepared. And just stay with it. And next week we get into some easy stuff. Okay. And gives us an opportunity to further consolidate what we know about the hard stuff. Okay. Especially rational functions, which everybody screwed up on the test. But I'm throwing out because not everybody got a rational function equation. Okay. Problem. Okay.